In lesson 8-4, we will solve equations with variables on both sides of the equal sign. So to do this, first we must simplify both sides of the equation just as we did before. So if there's any like terms, we need to combine those things. Then we can move variable expressions to one side. So anything with a variable will move to one side, either left or right of the equal sign. And we'll move all the constants, which are just single numbers, either positive or negative. We'll move the constants to the other side, so it's opposite of the variable. And then we can work to solve the actual problem for the variable. I prefer to do this in a certain way, so that way I'm always working with positive variables. So for step 2, it doesn't really matter which side you move the variable to. However, I like to keep my variables positive, so it's good to think about it before you actually move the numbers around. So for example, our first one here, I'm going to copy this down. 7x plus 4 equals 9x. Okay, so step 1, we're supposed to simplify both sides. Well, there's nothing to simplify. There are no like terms on the left. There are no like terms on the right. So now I need to figure out which side am I going to move the variable expression to. Well, this is 7x and this is 9x. Okay, well, if I move the 7x from this side over there, what I need to do is I need to subtract 7x from both sides. Well, when I do that, I compare the two. Basically, whichever one is greater in value, that's what I'm going to leave alone. So 9x is greater in value, so I'm actually going to leave it right over there. So that way, when I move it, I'm going to end up with a positive variable expression. So I'm going to subtract 7x on both sides. And then I can move my 4 straight down, and I'm left with 2x. Now I'm going to divide both sides by 2, so I can get rid of the coefficient, and then x equals 2. So now if I check that solution, well, 7 times 2 is 14, and 14 plus 8 is 18. And 9 times 2 is 18, so 18 does equal 18, and that worked out. Alright, for example 2, I'm going to copy this problem again. 3x minus 2 equals 8x plus 13. Go ahead and change your subtraction to addition. So again, look at your two variable expressions. I have 3x and I have 8x. Well, first of all, there's nothing to simplify over here, and there's nothing to simplify over here. So now, look at your variable expressions, 3x and 8x. Well, 8x is greater, so I'm going to leave it there. So that means I'm going to move the 3x over to that side. Well, to get rid of it over here, I have to subtract 3x from both sides. Please just do one step at a time. Your work should look just like mine. So this is 0. I'm going to move my negative 2. Remember, I changed it to addition, so it is a negative 2 down. Now I'm going to change this to 5x, and then I'm adding 13. Now this just turned back into a two-step problem, so I'm going to get rid of my addition subtraction first. So I need to subtract 13 on both sides. Alright, so then I can bring my 5x down and my equal sign. And if I owe $2 and I owe $13, that means I'm going to owe 15 altogether. And now we need to divide by the coefficient on both sides. So that way the coefficient turns into 1. And so x is going to be equal to, now this is a negative divided by a positive, so it's going to be a negative 3. And that is my solution. And of course, you always want to check your solution at the end. So 3 times negative 3 is negative 9, and negative 9 minus 2 is negative 11. So let's think about this one. 8 times 3 is 24, so 8 times negative 3 is negative 24, plus 13 also gives you negative 11. So negative 11 does equal negative 11. That works. Alright, for example 3, the measure of an angle is 8 degrees more than its complement. Okay, now a complementary angle, it's important to know that a complementary angle is two angles equal to 90 degrees. A complementary angle. The C kind of reminds me of a corner, and a corner is a 90-degree angle. That's a bad angle right there. But think of it like a right angle corner, like this, and a corner has 90 degrees. So complementary and corner. So let's go ahead and write this expression here. So 8 more than, there's the flip it sign, and then it's complement. So the complement would be the part that makes it the 90 degrees. So the measure of an angle is 8 degrees more than its complement. So if x represents the measure of the angle and 90 minus x represents the measure of the complement, what is the measure of the angle? So what we need to think about here is 90 minus x is the measure of the complement. So 8 plus, we're flipping, and remember this is the 90 minus x part here, okay, and then that's going to be equal to our x, okay, because it's 8 degrees more than the complement, and that's what's equal to that x, okay, so that represents the measure of that angle. So, okay, let's go ahead and write this correctly. So we have 90 minus x plus 8 equals x. Alright, so we do have something to simplify here, the 90 and the 8. So I'm going to get 98, and I'm going to say plus negative x equals x. Alright, so now think about it here. Which one's greater, a negative x or a positive x? Well, the positive x is greater, so I need to add x because this is a negative x, so to get rid of it I have to add x. Add x to both sides. So this is actually 0, and I'm going to get 98 equals 2x. Now I need to divide both sides by 2. So I get the coefficient of 1, so x equals, okay, and I know that, you know, half of 90 is 45, so I'm going to have 45, and then half of 8 is 4, so I'm going to have 49 degrees. Okay, so that's our missing measure there. All right, so let's check our other example. It says write an equation to find the value of x so that each pair of polygons has the same perimeter, then solve. Well, okay, so I need to write an equation here to find the perimeter of this, and then I want to have the same perimeter. So that perimeter is going to be equal to this one. So this is going to take a little bit here. Let's go ahead and write x plus 4. Okay, and I'm just going to put parentheses around that because that's one side. I'm going to say x plus 2 plus, and then I'm going to have x plus 5. And that is going to be equal to, now I'm actually going to have two of these because there's one here and one here. So I'm going to say 2 times x plus 3 plus, and I'm also going to have two of these. So I'm going to say 2 times x plus 1. Alright, so we have quite a bit to do here. I see that I have the distributive property to work with over here. Over here I can combine some like terms. So let's go ahead and I'm going to underline all my like terms. All these x's can be combined. All my constants can be combined. So let's take care of our left side here first. So I'm going to have 1, 2, 3 x's. So that's 3x. That looks a little bit nicer. Then I have 4, 6, and then 11. So I'm adding 11. So this right here, this expression looks a lot nicer than all of that. Now over here I need to do some distributing. So I'm going to have 2x plus 6 plus, now I'm going to distribute this one, I'm going to have 2x plus 2, and now I need to combine like terms. So let's rewrite this side. 3x plus 11 equals 4x plus 8. Okay, which variable expression is larger? Well, 4x is bigger than 3x, so let's get rid of the 3x. So whatever you do to one side, you have to do to the other. Okay, so we're just left with the 11 over here, and I'm left with just plain x, which is great, because then we don't have to divide by anything. And now let's get rid of this positive 8, so we subtract 8 on both sides, and so x equals 3. Okay, and so to solve for x so that both perimeters are the same, whatever x is, we need x to be equal 3 in order for both perimeters to equal the same here. And since that is just an expression, we're not going to include any units at all because it's x plus 4. That's an expression right there. So we're not going to worry about any units for this problem. Alright, if you pay a one-time fee of $30, you can purchase gold tickets for your local minor league baseball team for only $3 a game. So that's like per or each. Regular tickets sell at the stadium for $6. So how many games would you need to go to for the prices to be equal? Okay, so let's read that again. If you pay a one-time fee of $30, you can purchase gold tickets for your local minor league baseball team for only $3 a game. So that'd be like 3G. Regular tickets sell at the stadium for $6. So that would be like 6G, $6 per game. So how many games would you need to go to for the prices to be equal? Okay, so in order to get these gold tickets, we'd have to pay $30 plus $3 a game. And we want to know, when is that going to be equal to the $6 per game price? How many games do we have to go to in order for that to be equal? So again, which variable expression is greater? Well, the 6G is greater, so let's get rid of the 3G by subtracting 3G on both sides. So I get 30 is equal to 3G, and now we can divide by the coefficient on both sides. So G equals 10, and what that stands for is 10 games. You would have to go to 10 baseball games in order for this deal to be equal to just a single game price. So if you're going to go to 10 games or less, you can do 10 games. If you go to less than 10 games, just pay for the single ticket price. If you're going to go to exactly 10 games, it doesn't matter which deal you do because it's going to be the same price. If you're going to go to more than 10 games, then you'd want to do this other package here where you pay $30 up front. Okay, so if you'd like to see more examples, be sure to check out the online tutorials or check out the step-by-step homework helper for 8-4.